All right, so continuing on with section 7.3 homework, we have a cell tower that casts a 100-foot shadow. At the same time, a 4-foot 6-inch post near the tower casts a shadow of 3 feet 4 inches. We need to find the height of the tower. And so if we think about, here's the tower, cell phone tower, and it's casting a 100-foot shadow. And then we also have a post nearby, and we know that the post is 4 feet 6 inches, and it is casting a shadow of 3 feet 4 inches. And so we can see that if we were to figure out this value over here, we would be able to know the height of the tower. And so I'm going to set up a proportion for this, and I'm going to say first thing I need to do is I need to look at these measurements, and if this is 4 feet 6 inches, there are 12 inches in a foot, so I'm going to make this 4.5 feet, or 4 1/2, or if you wanted to put it as 9 halves, that would work too. And if we look here, this 3 feet 4 inches, that 4 inches, there are 12 inches in a foot, so that's 1/3 of a foot. So what we actually have here is 3 1/3 feet, and so that's going to be 10/3. I'm going to leave that as 10/3 because I don't want to approximate that answer. And so when I go to set up my proportion now, I'm going to say that the x here and the 4.5 is going to be equal to 100 and then 10/3. So then when I cross multiply here, I'm going to have 10/3 x equals 450. And then I'm just going to go ahead and use a reciprocal on both sides. And so then x, when I take and multiply 450 times the 3/10, that's how we're going to get the 135 feet. So definitely need to be careful with those inches, that we are working all in the same units to get to that height of the cell phone tower. Okay, all right, so just make this a little bigger here. We have some problems on this page that we need to look at. So looking at number 9, determine whether triangles are similar. If so, write the similarity statement. If not, what would be sufficient to prove the triangles are similar, and explain your reasoning. Okay, so if we look here, I'm going to start by doing proportions and see what I find, because there's no information given about angles. We'd have to know, for us to be able to use any type of angle here, we'd have to know that we would have some parallel lines, and we don't have that information. So I'm going to first start with 10 to 14 and reduce that. That's going to be 5/7. And then if I look at this side here, if I go 5, then this whole entire side here would be 5 plus 2, or 7. And so that gives us the second side. So we got 5/7 and 5/7. And so then when I go to look at the third side, this would be an 8. And when I add together this whole side here would be 8 plus the 3.2, so that's going to be an 11.2. So what I would do is just take that 5/7 and realize when I take that to decimal, that's 0.71. And if I take 8 and divide it by 11.2, that is going to be approximately 0.71. And so therefore I could see that I have all three sides in proportion. And so therefore that's how I know that I'm going to be able to say that yes, that these two are similar by side similarity. All right, looking at number 10. Number 10, we are given no information on the angles. We're given no information on the sides. The only thing that we could be able to say is that, angle A here would correspond to itself. So we would need to have this be parallel to this so that we could get other angles and be able to use angle similarity. Right now we don't have that information, so our answer would be no. All right, so looking at number 11. Number 11, we can see that we have an angle already, the 38 degrees and the 38 degrees. I don't see where we have any other way to get information about the other angles, so I'm then going to look at sides and see if that will work. And so if we take the 6 and the 10 here, if we divide by 2, that'll be 3/5. And then if we take the 9, which is this part right here, and then we need this whole right here, which is 9 plus 6, which is going to be 15. And if we reduce that, that's going to give us the 3/5 there. So now we have a side, we have an angle, and we have a side. And so we do have enough information to say that yes, they are similar. And once again, make sure that however you are starting this first triangle, how they've done here, triangle CBA, that it matches up correctly with the second triangle. All right, so if we look at number 12 and number 10, if you look at it, the big difference is in number 12, we're told that those lines are parallel. Once we're told that those lines are parallel, we know that we have angles in there and that are going to be corresponding. So if we know that we have two parallel lines, here and here, cut by a transversal, that if we look at the way this is situated, we obviously know that J is congruent to itself, but then we have this transversal now coming through here, and we have corresponding angles that would be congruent, and therefore that gives us enough information to be able to say that yes, these are similar, because we can get that angle similarity. Move this up a little bit here. Alrighty, so for number 13, what we are looking at is if we're given an angle and an angle, but no other information that's going to help us get another angle. So the only other thing then we can't use angle and we can't use side angle side. So we would have to try to use side. And if we look at this, we don't have enough information to determine this. If we started to try to do some similarity here, or to look for proportions, we would need to either know that this side JH here was a 3, or that this side WY would be a 24, and then that would make the scale factor of everything 1/6. But we can't just draw that conclusion. We don't have enough information for that, and so that's why our answer for that is no. For number 14, if we look at what is here, we know that the sum of the interior angles of a triangle is 180. And so if this first triangle has a 47 and a 68, that would make this angle in here a 65. And so the 47s would be good, but this is a 59, which is clearly not a 65 or a 68. So therefore, the angles of the triangles can never be congruent, so therefore the triangles cannot be similar.